there is another rule called as chain rule, which looks similar to product rule, but it's not. So product rule is defined when function is multiplied with another function, whereas chain rule is used when a function is used within another function. Are you able to understand the difference between both? So here, f of x is a function, g of x is a function, f of x into g of x is the product of two functions. Whereas here what you have is f of g of x, meaning if suppose I have x square as one function, which I call it as f of x, okay, suppose I call f of x as x square, g of x as sin x. The meaning of this statement is x square into sin x. Whereas the meaning of this statement is f of g of x is there, no. So wherever x is there in f, I need to replace it with g of x. So f of g of x here means in the place of x, I'll replace with g of x. So it is sin x the whole square, it is sin square x. Am I clear? So whenever you have this kind of a function, you need to use something called as chain rule. I'll tell you how to use it. Okay. So this kind of a function is called as a composite function. Just for you to know the name, it's called as composite function, whereas this one is product of functions. Seriya? Listen. So y is equal to, for example, I have this sin square x. Then what I need to do is, see, for this one, if this is there, no. Y is equal to f of g of x is there, no. So y dash will be f dash of g of x into g dash of x. Okay, let me simplify it. Let me simplify it. Since you're seeing it for the first time, instead of dealing with sin square x, let's say you have y is equal to sin 2x, for instance. See, sin x is the function. Sin of, whenever you have this kind of thing, it will become a composite function because it is not 1 here. Then how do you do this is y dash is equal to, you differentiate the main function. What is the main function here? Sin. What is the derivative of sin? You write cos, but you don't write cos x. You will write derivative of g of x. You will write it as cos 2x into, you will differentiate this 2x. This is the answer. This is called as chain rule. Okay, this you will not use it mostly as of now. There you will use it maybe in the 4th chapter. That too, I'll teach you one derivation of my own method. At that time, I'll show you how to use this. But as of now, if you know this, it's enough. Okay. So just to clarify, if suppose I have y is equal to, let's say, cos 7x. So what is y dash? Minus sin of, write the value as it is. 7x into derivative of 7x. Sorry. Into 7. That's the answer. So you finally report it as minus 7 times sin 7x. This is called as chain rule. Why I told it looks similar is because you are multiplying only. It looks similar. Right? I hope it is clear, no? Right. Make a note of this. For which one? This one. Huh? You cannot do no because it is not cos x into 7x. It is cos of 7x. There is a difference. Okay. That's why, see, I don't want to stress much on this one. Once you understand the basics, right, I'll teach you how to do it. Maybe 5 to 10 examples, you yourself will solve it. Not a big deal. You need not wait till 12th. Okay. But one thing is, let's first understand the basics. Because I know too much of information I've gone today. You need to work on those things. Right. But I promise you that I'll make you understand why we are studying this with the help of physics. right? See, in your lower grades, you would have seen this equation V is equal to U plus AT. What is this? It is basically one of the equations of motion, right? This is one of the equations of motion. Under what concept? When an object is moving under constant acceleration. When an object is moving under constant acceleration. Am I right? Now see, what is the basic definition of acceleration? Just to recollect, what is the basic definition of acceleration? It is called as rate of change of velocity. This you know already. So A is equal to, how can I write it? Rate means something changing with respect to time. So with respect to means that should be the denominator. So you put delta t. And what is changing with respect to time? Velocity. So change is always represented with delta. So delta v divided by delta t is acceleration. Okay. Then, is there a way I can write the acceleration as dv by dt according to differentiation? Can I do it? Can I write it? Yes. But the question is, when should I write this? When should I write this? So you need to have that clarity. So if you see A is equal to delta V by delta T, no, this is written for average value, whereas differentiation is written for instantaneous value. It is written for instantaneous value. So let me explain what I'm trying to say. So V is equal to U plus AT, right? Observe. If I bring U to the other side, then V minus U is equal to A into T. So V minus U divided by T minus 0 is equal to A. Why did I write T minus 0? I brought the T to the denominator. Instead of T, I wrote it as T minus 0. So V minus U is delta V. T minus 0 is delta T. This is what acceleration is. I just reversed the process. Because I wrote only T in the denominator. So if I need difference, I need a value. I have to write something minus something. That the other something is 0. So I wrote it as delta V by delta T as acceleration. As of now, I hope this is clear. But the same thing, V is equal to U plus AT. Instead of dy by dx, in the place of y you have v, in the place of x you have t. So if I write this as dv by dt, then this will be equal to derivative of u plus derivative of at, the first algebra of functions. That's what I was about to say. U is a constant because initial velocity is fixed. So this is going to be 0. So this formula is derived when the acceleration is constant. So when a constant is multiplied with a variable, what can you do? You can bring the constant outside. So this will be a into derivative of t with respect to derivative of t. Derivative of t with respect to time is 1. But what is a? You're able to understand. So in this case, you found the instantaneous value. So when you differentiate something, right? When you differentiate a value, whether it is physics or mathematics, you are finding the instantaneous value. So the preposition used is very simple. So what they say is, I told you, differentiation is done to find slope of tangent so if you see the word at, you need to differentiate. Slope of line between 2 points. If you see the word between, you will directly find the slope, which is going to give you the average value. This is what you need to do. So now you understood when to use slope formula and when to use differentiation formula, right? When will you use? Wherever you are asked to calculate average value, you will use slope. Average means you will know some finite amount of differences. Whereas at some places, whenever you are asked to find the instantaneous values, you differentiate. Here, so but both they are going to give you the slope only, but they have a different context. Is the point clear? So you can make a note of this.